Let us get started with our OpenAI API lesson. Welcome to OpenAI API in Python. Learn how to use the OpenAI API. Get started with chat completions, embeddings, and more. No previous experience needed. Running the cell now. Let us understand what the OpenAI API is. What is the OpenAI API? The API connects your Python code to advanced AI models, like ChatGPT, for language, code, audio, and more. It lets you build smart, interactive applications easily. Running the cell now. Why might you use this API? Why should you use it? Automate writing, chatting, summarizing text. Build assistants, chatbots, search tools, and more. Add intelligence to your projects with just a few lines. Running the cell now. First, let us prevent unnecessary warnings from cluttering our output. We import the warnings package and turn off warnings. Import NumPy as NP. We set the random seed to 42 for reproducibility. This hides extra system messages, so we focus on learning. Running the cell now. This step shows how to suppress warning messages in your code, keeping your output clean and focused on key results. Although no visible output appears, it's essential for smoother automation when building chatbots or assistants, ensuring warnings don't disrupt your workflow. This small setup helps keep your projects professional and user-friendly. We need to access your API key that is stored securely in your environment. The OS module helps with this. We import OS. This lets us access environment variables. OS is a Python built-in for working with the operating system. Running the cell now. Here, importing the OS module sets us up to interact with system settings, such as environment variables. Although there's no visible output yet, this step is crucial for automating tasks like managing credentials or configuration in your projects. This aligns with our lesson on adding intelligence efficiently with just a few lines of code. Now, we grab your OpenAI API key from your system environment. This keeps your key safe, and you do not need to write it visibly in your code. This saves your OpenAI API key from your environment in the API_key variable. It is safer than typing secrets in your code. Running the cell now. Here, we're securely retrieving the OpenAI API key from your environment variables to keep sensitive information safe and out of your code. Notice there's no visible output because this step is about setup, ensuring your project can access the API seamlessly before automating tasks like writing or building chatbots. This highlights the importance of security in adding intelligence to your projects with minimal code. We need to bring the OpenAI Python tools into our notebook. We import OpenAI. This is the library that talks to OpenAI's cloud. Now we can ask the API to perform smart tasks. Running the cell now. Here, we've imported the OpenAI client library, which sets up the foundation to interact with AI models. Notice there's no printed output yet. That's expected because this step just prepares your code to send requests and receive intelligent responses in later sections. This initialization is crucial for automating tasks like text generation or building chatbots with just a few lines of code. Next, we make a client object. This will connect us to the API whenever we need it. Here, we create a client for our requests. A client is like your login to the OpenAI system. Running the cell now. This code initializes the OpenAI client, setting up the connection needed to start making requests. Notice there's no direct output here because the main purpose is to prepare your environment. This is the essential first step before automating writing, summarizing, or building intelligent chatbots in your projects. Before using the API, let us look at some keywords you will see frequently. Key concepts to know. Model, the AI engine, such as GPT-4.1 Mini. Completion, the text or result generated for your prompt. Endpoint, the specific function, like chat or embedding. Running the cell now. Let us ask the AI to say hello back to us. First, we add a comment to describe our goal. We use client.chat.completions.create to ask the model for a reply. We tell it which model to use. We provide our message as the user. The assistant will generate a reply. We print the result. The AI answers you. Running the cell now. The output shows a simple greeting response from the GPT-4.1 Mini model, demonstrating a basic chat completion. Notice how the generated text directly replies to the user's message, highlighting how the model serves as the AI engine that creates meaningful conversational completions when called through the chat endpoint. Now, let us see how the chat system processes our conversation. How chat completion works. You send messages in a list. Each message can have a role: user, assistant, or system. The assistant replies based on all previous messages. Running the cell now. Let us see how to guide the chat with a system instruction. This comment reminds us about controlling chat with roles. We create a list of messages for our chat. The system role tells the AI to act as a Python tutor. The user asks what a variable is. We finish setting up the conversation. We send our messages for a reply. We select the small model for efficiency. We give the chat history to the API. The result is saved. We print the assistant's reply. Now, it answers as a Python tutor. Running the cell now. This output demonstrates how the assistant uses the system's role prompt to adopt the persona of a helpful Python tutor and provide a clear, educational explanation in response to the user's question. Notice how the assistant elaborates on the concept of variables with definitions and examples, showing how the conversation context and roles guide its detailed, relevant reply. Next, we keep a conversation going with multiple messages. This comment explains multi-turn chats. We start a list with a system prompt. The system prompt sets the assistant as a math helper. The user asks a first math question. The assistant gives the correct answer. The user asks a second math question. We close the list of chat messages. We send a request to create a chat completion. We specify using the GPT-4.1 Mini model. We pass the full chat history as messages. We print the assistant's reply from the response. Running the cell now. This output shows the assistant continuing the conversation based on the full chat history, including the system's role and all previous messages. Notice how it correctly answers the latest user question, what is 3 times 5, illustrating how multi-turn chat completion uses prior context to generate relevant responses. Now let us look at another popular feature, embeddings. Embeddings, understanding text with vectors. Embeddings turn words or sentences into numbers. This helps AI compare meanings, search, and cluster text. They are useful for search engines and data science. Running the cell now. Here is how to get an embedding for a phrase. This comment states that we will get an embedding. We call the client to compute embeddings. We use the small, fast embeddings model. We provide our sentence as input. The embeddings are generated as a list. We print the number of values in the vector. It is large, showing the complexity of the meaning. Running the cell now. This output shows the length of the embedding vector generated for the input sentence. Machine learning is fun. Notice that the vector has 1536 dimensions, which is typical for this embedding model. This high-dimensional representation captures the subtle meaning and context of the text, enabling AI to compare and analyze language effectively, as the lesson explains about embeddings turning words into numbers. Let us make sure our program does not crash if an error happens. How to handle errors safely. Always catch exceptions when calling the API. This helps you show friendly messages if something goes wrong. Use try and except blocks. Running the cell now. Next, let us make our code safe from errors by wrapping in a try and except block. We add a comment about error handling. A try block means, try running this code. We call the API with a basic message. We select our model again. We provide the user's input. The closing parenthesis ends our call. If all works, we print the RS reply. If anything fails, we move to the except block. We print a friendly error message if needed. Your program stays safe. Running the cell now. This output shows a successful API response wrapped inside a try except block, demonstrating safe error handling. Notice how the program prints the assistant's helpful message instead of crashing, which aligns perfectly with the lesson's goal of providing friendly feedback when calling the API. This confirms that using try except ensures smooth execution even if the input is unclear or unexpected. Let us remember some important safety tips when working with APIs. Best practices for API usage. Keep your API key secret. Control costs by using smaller models if possible. Add pauses if you make many requests. Review the API documentation for updates. Running the cell now. Let us ask the user for their own prompt. A comment says we will use input for a prompt. We show a message and wait for the user's question. Input lets users type. We send the user's prompt to the API to get a response. We specify the model called GPT-4.1 mini to generate the answer. We provide a list with one user message containing the user's query. We finish the API call and get the result object. We print the content of the assistant's reply from the result. Running the cell now. This output shows a detailed, informative response generated by the GPT-4.1 mini model based on the user's input prompt. Notice how the concise explanation highlights Python's key features clearly, demonstrating how even a smaller, cost-effective model can provide useful, coherent answers. This aligns with the lesson's intent to control costs by choosing smaller models while maintaining meaningful API interactions. Now, you can type your own question and see what the AI replies. Now let us build a super simple chatbot that you can talk to. A comment says this is our mini project. We start an infinite loop to keep chatting. We ask the user for new input. If they type exit or quit, we say goodbye. The goodbye message will appear, and the program ends. Break ends the loop. Otherwise, we use the API to get a reply. We use the lightweight model for fast response. We use the user's message as input. The completion result is saved. We print the reply labeled as AI. Now you are chatting interactively. Running the cell now. This output shows a simple interactive chatbot responding to a user input with a joke before the session ends on goodbye when the user types exit or quit. The key takeaway here is how the loop efficiently manages continuous requests while maintaining the conversation flow, illustrating best practices in controlling API usage within a user-driven chat interface. Type exit or quit to leave anytime. Here is a quick test to check if your OpenAI API is working. A comment describes troubleshooting the connection. We start a try block. We attempt a basic call to the chat endpoint. We pick our standard model. We send a message asking for a test. End the request call. If it works, we tell the user the API is working. If it fails, we warn to check their key or network. Display the error if there is one. Running the cell now. This output confirms that your API connection is successful, as the test message triggered a valid response from the model. Noticing the API working fine message means your key is accepted and the network is stable, which aligns with our lesson's emphasis on verifying setup before scaling usage. This step is crucial to ensure smooth operation and avoid unexpected errors during actual API calls. It is time for a challenge. Challenge Exercise 1. Custom Prompt. Change the prompt to ask the assistant your favorite question. What is the most interesting answer you can get? Running the cell now. Try it out and see what you learn. Let us deepen your skills with a second challenge. Challenge Exercise 2. Multi-turn conversation. Build a chat history with at least 3 user and assistant turns. Guide the assistant using a helpful system prompt. Running the cell now. Can you make a realistic conversation using roles? Let us review what you learned. Recap what you learned today. You connected Python to the OpenAI API. You ran chat completions and embeddings. You made your own chatbot. You practiced error handling and best practices. Running the cell now. Congratulations! You are on your way to building smart apps. Thank you for learning with us. Thank you, and next steps. Like and subscribe for more Python and AI lessons. Practice by building your own fun mini projects. Happy coding with OpenAI. Running the cell now.